Have you ever taken a moment to look up at the night sky and noticed a glowing reddish star on Orion's shoulder? That brilliant dot of light is Betelgeuse, one of the most fascinating stars we can see from Earth. To the naked eye, it appears like any other bright star, but what you're actually looking at is something extraordinary, a colossal dying star nearing the final moments of its life. Betelgeuse isn't just large, it's one of the biggest and most unstable stars known, and someday it will end in one of the most violent and awe-inspiring phenomena in the universe, a supernova. What makes Betelgeuse particularly interesting is that its explosion is expected to happen relatively soon, at least in astronomical terms. The star could explode tonight, next year, in a century, or even 100,000 years from now. That window of time might sound enormous to us, but in the life cycle of stars, it's almost the blink of an eye. The uncertainty about when it will happen only adds to the fascination and the sense of anticipation among astronomers and stargazers alike. Betelgeuse is a red supergiant, which places it among the largest types of stars in existence. To understand just how massive it is, imagine replacing our Sun with Betelgeuse. Its surface would extend far beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and even the asteroid belt. In size, it's about 764 times wider than the Sun. In mass, it's over 10 times heavier. Yet despite its staggering scale, Betelgeuse is a young star by cosmic standards, only about 10 million years old. In contrast, our Sun, which is a much smaller and more stable star, is already around 4.6 billion years old and still has billions of years left. Massive stars like Betelgeuse burn through their nuclear fuel extremely fast. They live brief, brilliant lives and die young. As a star like this nears the end of its life, it begins fusing heavier elements in its core, progressing from hydrogen to helium, then to carbon, oxygen, and so on. Eventually, it reaches iron, an element that can't be fused to produce energy. At that point, gravity overwhelms the internal pressure keeping the star stable, and the core collapses in on itself. This triggers a supernova, an event so bright it can briefly outshine an entire galaxy. Stars don't die silently. They often give off warning signs that something big is coming, and in the case of Betelgeuse, one such sign occurred in late 2019. The star's brightness dropped dramatically, down to about a third of what it normally is. This dimming lasted for weeks, and it didn't go unnoticed. People around the world, both amateur stargazers and professional astronomers, were captivated. Was this it? Had Betelgeuse begun the process of exploding? The astronomical community quickly mobilized. Observatories across the globe and space-based telescopes focused their attention on Betelgeuse. Instruments like the Hubble Space Telescope, the Atacama Large Millimeter Submillimeter Array ALMA, and the Very Large Telescope in Chile began gathering as much data as they could. The world waited for an answer, and when it came, it wasn't the supernova everyone had hoped or feared it might be. Not yet, anyway. Instead, scientists discovered that Betelgeuse had experienced an enormous surface eruption. This event was similar in concept to solar flares from our Sun, but on a scale that's difficult to imagine. The star expelled a massive cloud of gas and dust, which drifted in front of it and temporarily blocked part of its light from reaching Earth. This created the illusion that the star itself had dimmed. The event came to be known as the Great Dimming, and it marked a significant moment in our study of stellar behavior. The Great Dimming wasn't just unusual, it was unprecedented. It was the first time astronomers had witnessed a red supergiant behave in such a way. This moment offered a rare, almost intimate glimpse into the violent and unpredictable processes occurring in the final stages of a massive star's life. In a way, we had caught Betelgeuse in the middle of a colossal cosmic sneeze. The scale of the expelled material was mind-boggling. The dust cloud that Betelgeuse released during the event was about 400 million kilometers wide. To put that into perspective, it's larger than the distance from the Sun to Mars. This was not just a small hiccup, it was a major eruption of matter from one of the most massive stars in our stellar neighborhood. Events like this remind us just how dynamic and powerful stars can be, especially in their final acts. Following this event, Betelgeuse became one of the most closely monitored stars in the sky. Continuous observation has revealed more curious features. For example, Betelgeuse appears to rotate faster than expected for a star of its size and type. One leading theory suggests that Betelgeuse may have consumed or merged with a smaller, companion star sometime in the past, which could have transferred angular momentum and sped up its rotation. This idea, while speculative, fits with other anomalies observed in the star's behavior and structure. Meanwhile, deep inside Betelgeuse, its core is still hard at work, fusing heavier and heavier elements as it burns through the final reserves of its nuclear fuel. Each new layer of fusion brings the star one step closer to collapse. Once the fusion process reaches iron, the core will no longer be able to resist gravity, and in a matter of seconds, the entire structure of the star will give way. The outer layers will be blasted into space, and for a brief time, Betelgeuse will shine with the light of 1 billion suns. When this supernova does occur, it will be one of the most spectacular celestial events ever witnessed by humanity. It could become so bright that it will rival the full moon in our night sky. Some predictions even suggest that it will be visible in daylight for several weeks. And while the event will release an immense amount of energy, we're in no danger here on Earth. Betelgeuse is far enough away, around 642 light-years, that we'll be safe from the radiation and shock waves. Instead, we'll get the rare privilege of observing one of the universe's most dramatic transitions from relative safety. And yet, no one can say for certain when it will happen. It could be imminent, or it might not occur until long after we're gone. The nature of stellar evolution doesn't provide precise timelines, only likelihoods based on models and behavior. From our perspective, the range between tomorrow and 100,000 years from now is frustratingly vague. But for astronomers, it's all part of the mystery and the beauty of the universe. In the meantime, Betelgeuse continues to shine. It pulses gently in the shoulder of Orion, a glowing reminder of the forces at work beyond our planet. It reminds us that the universe is not still. It is alive, dynamic, and filled with transformations too large and too slow for us to witness. Easily, but no less real. What appears to be a constant star is actually undergoing powerful changes, and someday it will deliver a final burst of brilliance that will echo across time and space. So, next time you find yourself under the stars, look up at Orion and find that glowing red light. Think of the forces at play inside that distant sun, and how, even across the vastness of space, we are able to glimpse the powerful rhythms of the cosmos. Betelgeuse may not explode in our lifetime. Then again, it just might. And if it does, it will be a show unlike anything the modern world has ever seen.